Okay, we're going to do a quick intro video on working with VEX. Most of you yesterday got grouped up on a sign-up sheet. You're in groups of 3, and you're going to be building different types of mechanisms. In fact, there's going to be about 8 different mechanisms you're going to build. Now, what you see here, this is called a base plate. This is the biggest metal piece that comes with the VEX kits. It's essentially a foundation. And what we're going to have to do is on the bottom of these, we're going to have to take a Sharpie marker and put your group number on there. These will go in the cabinets that pertain to your class period. So I have some cabinets in the back. They'll be sorted out per class. Now on this base plate here, anything that's attached to it will go in the cabinet. Anything that's not attached will need to go back into inventory. We can't have any loose pieces floating around, because there's just thousands of these VEX pieces, and I have to keep track of them for 6 periods of classes. Now, what you're going to start out with is you're going to have a tray. Each group's going to have a tray. I know it's kind of hard to see this. It's basically, there's a knob. There's a knob. It looks like a little drawer. Each class is going to have a cart of trays, and in the tray is going to be a picture of what mechanism you're working on. So for example, this is going to be a couple of mechanisms. We have a simple gear train, and we have a simple gear train with idler. On the bottom of this paper, it's going to have some basic parts that you will need. Now, most of the trays have been sorted out so that they're going to have the various parts that you need. We have gears. These square pieces are drive shafts, and they're square, so it doesn't look like they rotate very well. Well, to get those to rotate smoothly, we put them through these plastic pieces called bearings, and I'll get into more of that later. What you'll do is you'll start out with your base plate, and then you have to make this large metal bracket. For most of you, it's going to be made out of a couple of pieces. We're going to have one piece here. It's a wide U-channel. It's not quite as long as your base plate. And then we're going to have a flat metal plate here. So it's going to get made with these 2 pieces of metal. And they're going to be threaded into these spacers here. So these black machine screws get threaded into these spacers. Now if the machine screws are too long, they'll bottom out. So you got to make sure that you start with short machine screws. To talk a little bit about how the bearings work after you make that metal piece, if we just kind of use this as an example, you can place a metal bearing in this metal girder here, and actually it'll go on your flat metal plate. So let's use that as an example. So on your flat metal plate, you'll have this piece here. Here's one that has a screw in it, so maybe I'll use that as an example. So that'll get placed in there. And you'll have to get it's a star nut. It has a star washer on it. If you look closely, you see that star washer. The washer has to face the metal plate. It will tighten into the metal plate with an Allen wrench if it's facing the right way. If it's facing the wrong way, it won't tighten down. And I don't have any Allen wrenches with me right now, but there's a whole bunch of hex wrenches that fit in to the end of that bolt. Now you want to use 2 of them, and you want to place them where they won't get in the way of the axle. So I got 2 of those, or the drive shaft. I said axle, drive shaft, either works. You'll also want to place it on the black plate so that they line up. But as you can see, when I put the drive shaft in that bearing, it's going to spin a little more smoothly. And then I can place any gears over the end. Now if I left this like this, the gear is going to slide in and out. It's going to have a hard time staying in place. So one way you get these to stay in place is with these collars. These little collars here, they slide over the drive shaft, and it just kind of depends on where you're at on your width. but you're going to want to use 2 of these collars per drive shaft. And they also have a little Allen screw on the inside of them. Now with these Allen screws, it's very important that you do not over tighten them, because they'll strip out really easily, and then essentially these collars become useless. But once they're snugged down with that Allen wrench, they'll stay in place. And then they'll spin. It'll spin without falling out. So this would place one gear in the right location. Now you're going to have to kind of do some experiments depending on what your mechanism is to figure out where your pieces are going to fit. And you'll want to do that before you bolt it down. So if you're doing a simple gear train, grab another drive shaft here. A simple gear train, you're going to want it to mesh up with this gear. So you might want to place it in there, figure out what hole that drive shaft needs to go through, and then you can bolt that one down in place. So I'll take a machine screw, star nut, make sure the star washer faces towards the metal bracket. And again, you want to do 2 of those so it doesn't flop around. If your pieces aren't snugged up, your mechanism may not work properly. It could be sloppy. The gears could skip. And if I have that in the right place, these gears are going to mesh together. And so here's how a simple gear train would operate. The shaft that I'm turning would be the input shaft. So you see my hand on that bottom drive shaft. That would be the input shaft. The one over here that's spinning is the output shaft. Since the gears are the same, my speed is going to be constant. There's also another measurement that we use. It's called torque, T-O-R-Q-U-E. And that's a measure of power. And if the speed increases, the power decreases. Since these are the same size, speed is constant and torque is constant. Now, what changes is the direction of force. So if I'm spinning one clockwise, the other one's going counterclockwise. If I wanted them to go the same direction, I'd want to place an idler in the middle. And that idler pulley would get these 2 gears to spin in the same direction. And you're going to have to work a little bit on getting those all together in the right order. So that's just one example. I'll have a few more videos that I'll put together on the different other mechanisms. I know there's crank and slider, worm and wheel, universal joint, rack and pinion. But again, you're going to start out with a big base plate. You're going to have to get some metal pieces to build the girder that gets bolted on your base plate that will support your mechanism. You're going to want to use these plastic bearings so that the square drive shafts will spin smoothly. And then remember, to hold the drive shafts in place, you'll want to use these little collars with the Allen screw and get those snugged up. When this is all together, or at the end of the period, well, for example, at the end of the period, if it's not finished, you're going to want to leave everything fastened to the base plate. It's going to go in our cabinet. Any loose pieces will go back in the drawer, and it'll go back on your class's cart as there's assigned carts. Any pieces that leave the room, Mr. Yeoman will be notified and he will hunt you down. So for now, good luck.